Hi everyone, I'm Guoqiang Ren, a PhD candidate from Zhejiang University. It's my pleasure to share some information on our research, mobile robotics platform for strawberry inspection and harvesting within precision indoor farming systems. My presentation will cover the following topics: the importance of strawberry production, our overall research goals, systems analysis of research concept, research methods, some key experimental results, and concluding remarks. Global strawberry production value increased by 94% in the past 20 years. In 2019, the production value reached $14.5 billion. The production reached 8.9 million tons under the leading contributions of China, US, and Mexico. Robotics has been found to be important in addressing the challenges of repetitive manual tasks, high labor costs, selective harvesting, quality of harvested fruit, and etc. Our overall research goals are to develop a mobile robotics platform (MRP) for strawberry cultivation tasks, leading towards intelligent agricultural systems, conduct efficient near real-time monitoring of all individual strawberry fruit and plant within a whole precision indoor farming systems (PIFS), perform production estimation and harvesting planning and execution for a whole PIFS, provide spatial temporal data support for genetics, environment, and management research on interaction mechanism of plant, environment, automation, and cultural tasks. This presentation will cover the first two research goals. The concept of research involves the development of a mobile robotics platform for plant growth monitoring and fruit harvesting, supported by the capabilities of mobile robot autonomous navigation and sensing. The robotic strawberry harvesting pipeline followed a See, Think, Act strategy, involving machine capabilities of perception, reasoning learning, task planning, and execution. RGB and depth images were captured by the real-size camera, which was mounted on the gripper. We used deep learning technology to capture the 3D location of target food. Based on the detection results, a heuristic strawberry scene categorization precise was carried before performing executable harvesting actions. A novel fruit detachment motion, drag and rotate, was carried out to realize the non-destructive robotic harvesting. Here are the highlights of experimental results. YOLO V4 technique was used to detect ripe strawberry fruit with an MAP of 95% and unripe fruit with an MAP of 80%. Examples of two of the five scene categories are shown in this slide: multiple fruit with separate images and multiple fruit with overlapping images. We have defined five scenes in the right figure. A is clearly visible fruit, which is separated from the others. B represents a visible whole fruit, with other unripe fruit directly behind. C is a visible whole fruit, with other ripe fruit directly behind. D signifies the visibility of a fruit is less than 50%, and E means the visibility of a fruit is 50% or more, but less than 100%. The final results are shown in the confusion matrices. The overall accuracy is 91%, and the macro F1 score is 78%. Non-destructive robotic harvesting motions were carried out as inspired by manual harvesting. The novel fruit detachment motion, namely drag and rotate, as shown in the video. A fruit can be gently grasped by a soft effector and separated from the fruit end of a peduncle with a force F1 and a torque M1. 50 fruit harvesting attempts were made, with 44 scenario A's, 2 scenario B's, and 4 scenario C's, within a commercial PIFS in 4D Bells company in Hangzhou, China. The overall successful rate was 88%. The average cycle time was 10.5 seconds, including detection, grasping, detachment and placement time. They have found that the performance was better in harvesting fruit of small size. Most grasping failures occurred when the fruit had a long peduncle, and most detachment failures occurred when the fruit had a large body mass. The progression of our work is to make things work better, together, and smarter. We developed a heuristic approach to fruit scene categorization for identifying executable harvesting actions, a novel fruit detachment approach to anti-factor motion planning based on manual harvesting. A soft anti-factor was used to realize non-destructive fruit harvesting. The MRP has the abilities to monitor and harvest strawberries within precision indoor farming systems. In this presentation, the focus is on making things work better. It is our plan to optimize both the facility-wide production strategy and individual fruit harvesting motion in the future. Your questions and comments are most welcomed. Please contact me at the email address shown here. Thank you very much for the opportunity to make this presentation.